In this question we are given a family of functions f of x, which is 1 over x squared minus 2x plus k, where k is a constant. And we need to find the value of k for which the slope of the line tangent to this function at a point x equals 0 is equal to 6. So let's find what the slope of the function, or slope of the line tangent to the function is, and that is the derivative of this function at that particular point x equals 0, the point 0. So let's differentiate. Let's first rewrite this as x squared minus 2x plus k to the negative 1 power. And so we need to take the derivative of this expression, and using the chain rule, this is negative 1 times x squared minus 2x plus k to the negative 2 times the derivative of what we have here, which is 2x minus 2. So let's now plug in x equals 0. F prime of x at 0 is equal to, plugging in 0 gives us negative 1 times k to the negative 2 times negative 2. So this is equal to 2 over k squared, and this is given to us, this is equal to 6. So multiplying by k squared both sides and dividing by 6 gives us k squared equal to 1/3, or taking square roots, given that k is positive, k is equal to square root of 3 over 3, and this is our final answer. So in this part of the question we are given the specific value of k, and the question is to find the value of this definite integral. So let's first plug in k into the function and see whether we can simplify it a little bit. We get 1 over x squared minus 2x minus 8, and we can use partial fractions in order to find this integral. So let's factor first the quadratic equation, and that the solutions here, as you can check, are x minus 4 and x plus 2. So the solution is 4 and negative 2. And so we need to find such values of a and b, is that a x minus 4 plus b x plus 2, that this is true, and a and b are just some constants. So how do we do that? We multiply both sides of this equation by x minus 4 and x plus 2, and we get 1 equal to a x plus 2, and then plus b x minus 4. And so this equation should be true for all values of x. And so let's plug in, for example, first value x equal to negative 2. This cancels out, and we get 1 equals, plugging in negative 2 here gives us b times negative 6, and it follows that b is equal to negative 1 over 6. Similarly, plug in, instead of x, plug in 4, we get 1 equals a times 4 plus 2, 6, and therefore a is equal to 1 over 6. So let's now write what this integral is. This integral from 0 to 1 f of x dx is equal to integral from 0 to 1. A is 1 over 6, 1 over x minus 4 dx, plus integral from 0 to 1, and in this case negative 1 over 6, times 1 over x plus 2 dx. this is equal to, we can then take 1/6 outside, 1/6 ln of the absolute value x minus 4 minus 1/6 ln absolute value x plus 2. And this has to be evaluated at points 1, 0 and 1. So plugging in those values, we get 1/6 ln of 1 minus 4, absolute value is 3, so ln of 3 minus 1/6 ln 1 plus 2 ln of 3, that's, we plugged in 1 and now plug in 0, minus 1/6 ln 0 minus 4 is 4, absolute value, ln of 4 minus minus plus 1/6 ln of 2. So simplifying this, cancelling out this cancels out with this expression, and then 1/6 ln of 4 over divided by it will be ln of 2. So simplifying this, you actually can see that this is negative 1/6 ln of 2. And this is our final answer. In this part of the question, we are given a different value of k equals to 1, and the question is whether to find the value of a definite integral or to show that it diverges. And so let's see what this integral is. Integral from 0 to 2, 1 over x squared minus 2x plus 1 dx, and we can see that this is actually x minus 1 squared, so this is integral from 0 to 2, 1 over x minus 1 squared dx, which is improper integral because somewhere on this range between 0 and 2, x minus 1 is not defined for x equals 1. Right? Let's break this into integral from 0 to 1, 1 over x minus 1 squared dx, plus integral from 1 to 2, 1 over x minus 1 squared dx. And because this is an improper integral, we define this as a limit, as in this case b goes to 1 from the left, and b is such that this is integral from 0 to b, 1 over x minus 1 squared dx. So the upper limit here approaches 1 from the left, and we find the value of this integral, and that integral by definition will be this integral by definition of the improper integrals. Plus the second integral is also improper integral, and so limit as b goes to 1 from the right, limit from b to 2, 1 over x minus 1 squared dx. And so this integral we can find, this is really u substitution x minus 1 equals u, and then so 1 over u squared du, because this is a simple u substitution, and so the integral is equal to limit as b goes to 1 from the left, and here we have negative 1 over x minus 1 evaluated at points 0 and b, plus second integral is similar, b goes to 1 from the right, negative 1 over x minus 1 evaluated at b and 2. And so this is equal to, we can plug in b in here, b and 0, and this is equal to limit as b goes to 1 from the left, negative 1 over b minus 1 minus 1 here plus limit as b goes to 1 from the right, in this case negative 1 plus 1 over b minus 1. And we can see here that this limit as b goes to 1, negative 1 of negative 1 over b minus 1 does not exist. So this limit does not exist. And this second limit as well does not exist. So actually this means that this integral that we are being asked to find diverges. So it diverges, and this is our final answer.